In today's video, we're going to continue adding and subtracting irrational numbers, which will be our integers and our fractions. So let's just start on number 3 and go over some of the basic rules. So remember the rules for integers. Again, when they're simple like I, you're not going to confuse yourself with some rules. You're just going to go 5 minus 3. It's just when you get to questions like I, you might want to start applying the rules. For example, I would maybe reconsider rewriting that as an addition statement like you do for all subtraction of integers, and you write it as negative 5.1 plus, and as it sits right now, that's a positive 3.3, so you would rewrite that as negative 3.3 because you go opposites. And now the rule states when I'm adding integers and the signs are the same, I can keep the signs and I can just add the numbers to get an answer of negative 8.4. Again, I can rewrite a question like this as an addition statement. I change the subtraction to addition and I change the sign of the second number. Now the rule states when I'm adding and the signs are different, I take the sign of the largest number and now I just subtract 5 minus 3 to get a positive 2 as an answer. So sometimes it's easier to use the rules. In this situation you wouldn't use the rules. This one you would just subtract normally. On situations like possibly here, you might want to rewrite this as an addition statement. You might want to rewrite this one as an addition statement. Let's move this up. So this question asks which one has the same answer as negative 7.2 minus 1.8. First thing you're going to do is when you're comparing is it all needs to be the same. So find the standard form of all these answers. Find the answer to each one of these, and then it'll be a lot easier. Or you can rewrite them so they look the same. For example, write them both as addition statements. This is minus 7.2. I'm going to rewrite this as an addition. This is a positive number, so I'm going to write it as a negative number. And now I can just go down here. These two match. I can rewrite this one as 1.8 plus positive 7.2. So we know these two don't match. And then you do these two, rewrite them, and see if they match. Or you can just actually figure out what the answer for this is going to be, and then compare all four. Either way is fine. I would probably use this just to rewrite them as an addition statement, and then it might be an easier way to compare. You'll save yourself some time, but whatever works for you is great. Okay, number 5. So number 5, we're dealing again with positive and negative numbers. I would rewrite that as an addition statement. Minus 11 plus a negative 2, because there's no sign here, so we assume it's positive. You don't need brackets, but I like putting them in. The rule states when I'm adding and the signs are the same, I keep the sign and I add the two numbers. That holds true with fractions as well. So rewrite this as an addition statement. I change the subtraction to a addition. I change the sign on the second number. And now I have a fraction question. And it says, when I'm adding and the signs are the same, I keep the sign and I add the two numbers. So this gets a bit more complicated because now you're dealing with fractions. Remember, if the denominators are the same, then I can add the numbers and then I can leave the denominators. You would then turn this into how many times does 5 go into 13? Twice, with 3 over 5 left over. Now again, This doesn't have to be shown, but you might want to put the positive 2 in there just to make sure. And then number 9, we'll do one. Let's randomly pick. Okay, so we don't have common denominators. You might want to rewrite this as an addition statement. Again, you don't have to, but first things first, let's convert those mixed numbers into improper fractions by going 1 and 5 over 6. I multiply the denominator by the whole number, and then I add the numerator. So 6 times 1 plus 5 is 11 over 6. And I'm going to subtract 4 times 6 is 24, plus 3 is 27 over 4. The common denominator can be 12, which will give me 22 over 12, minus 54 over 12. Now again, the rule states when I am subtracting or adding fractions, I can leave the common denominator and then I can just deal with the tops. So essentially this is saying 22 take away 54. You might write this as 22 plus a negative 54. Again, you don't have to on questions like that, but I always like using the rules. And now the rules state when the signs, or when I'm adding and the signs are different, I keep the sign of the largest number and then I subtract the 2. So 54 take away 22 is 32. And my answer is going to be a negative 32, which then I'll drop down here. And then I say how many times does 12 go into 32, which is twice, and there'll be 10 left over. Nope. 8 left over 12. And I apologize for the space. I'll try to move it over a bit if I can. Which then I can divide top and bottom by 4. We still have a negative 2 and 2 over 3. And that will be my final reduced answer, left as a reduced answer and left as a mixed number. So let's go to the next slide. So in this question here, we'll look at some targets again. Your targets for this worksheet will be, do you have the ability to add and subtract integers, fractions, and decimals? And can you find the missing values? So finding the missing values, we'll use a little bit of algebra, and we can figure that out. So for example, let's do one on number 13. And we'll just pick, this one looks like a good one. I'm going to rewrite that first of all with common denominators and an addition statement. So common denominators in this situation. So our common denominator in this situation, it's a little bit tougher. So I'm just going to multiply all the bottoms together just for the sake of ease, and it looks to be that will be the common denominator of 60. So I will rewrite this as negative 60. And I don't really know the tops yet. I'm just going to rewrite this. I'm going to change that to an addition sign. I'm going to change that to a plus number, 60. And because that's adding, I'll leave it. I'll leave 60 on the bottom. So I multiplied these guys together to get 60. 5 times 12 gives me 192. I multiply 3 by 20 to get 280. And I multiply 4 by 15 to get 195. Now the trick in this situation was, if I say, well, what do I multiply 4 by to get my numbers? I just multiply 3 and 5. What do I multiply 3 by I multiplied 5 and 4. And what did I multiply the 5 by? I multiplied the 5 and the 4. So that was just kind of a quick way of doing it. Now I have fractions, all common denominators. I'm dealing with integers, and I'm adding all addition statements. So now the rule says I can add the tops, and I leave the denominators. So I have negative 192 plus positive 280 plus 185. And I get negative 192 plus positive 280. The signs are different, and I'm adding, so I keep the sign of the largest number. And I subtract those two to get 88. And then I have 88 plus 195. And I'm adding, the signs are the same. I keep the sign, and I add the numbers. Now I need to know how many times is 60 going to the top number. 60 goes in the 283 4 times, with 43 left over, and it's a positive answer. So my answer is positive 4 and 43 over 60. So let's do these ones too. Let's just pick number A, an unknown, subtract 28.4 is equal to 37.3, and the rules of algebra says if I want the unknown by itself, I just do its opposite. That cancels, and so I say positive 37.3. I'm going to add to it 28.4, and I get 7. Again, I'm lining up my decimals. That's it's a rational number, so let's review that. 8 plus 7 is 15. Carry the 1, and my answer is positive 65.7. That holds true for all of these. Now, a question like number F is a lot more tricky. The reason it's tricky is because first thing you're going to do is you're going to remove this by adding 3.5 to both sides. So you're going to want to convert that to a improper fraction by going 2 times 3 plus 1, which is 7 over 2. Okay, so you're going to add these two numbers, but then the tricky part is you still have a negative on this side. To get rid of a negative, essentially you can look at it as like that's a negative 1. And to get rid of a negative 1, I can multiply both sides by a negative, because we know negative times a negative is a positive number. So for example, I'll give you an example. Negative an unknown is equal to 4. It doesn't really matter what it is. If I want to get rid of this negative, I can times this side by negative 1. I multiply this side by negative 1. Essentially, this is negative 1 times negative 1. Negative and a negative is a plus 1, and that gives me my unknown, which is good, but it doesn't really matter what's on the inside. If I multiply by plus 1, it just makes it positive, which we need. If I multiply this side by negative 1, I must multiply this side by negative 1. So 4 times negative 1 is negative 4. So my answer would be negative 4. That's going to have to be applied to this somewhere when you're dealing with this negative here. Essentially, all you're going to do is you're going to drop the negative on this side, and whatever sign you get from this answer, you're just going to change it to its opposite. Hopefully that part didn't confuse you too much. If it does, just come see me and I'll show you some more examples, and it will make it clear, because you'll be doing it with all of these types of questions. So it's an easy fix if you don't get it, so just come and see me. Hope that helped.